Counting principle, the most basic one, and we looked at case 1 whereby we had a menu. Now let's look at a case where we arrange different things. For instance, if you have got case 2, this now if you have different people sitting, let's say girls and boys sitting. Maybe you have got 5 girls and this is case 2.1. Let's call it case 2.1 because I'm going to talk about that. And then let's say here we're talking about even. So we're talking about an even number of people. So if there are 5 girls, then there will be 5 boys. And somebody asks you how many different ways can they stand in a queue. So I'm going to represent the girls with the black color. So the girls can stand, all the girls in front, 1, 2, 3, 4, 5, and then all the boys behind the girls, 1, 2, 3, 5. Do you see that? So in other words, they can stand in that combination, or you can stand one girl there and then another one there, and then you have all the boys following the one girl. There are many different combinations, sorry. Then the other girls like that. So now if we wanted to know how many different ways we can arrange 5 girls and 5 boys without any condition, they just stand in whichever way they want, it means that, and I'm going to use this case so that everybody understands, it means that we have got how many people? We have got 10 people. Now if I want to find out how many different ways I can arrange 10 different people without any condition, I am going to say 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. This is the number of ways in which you can arrange 10 different people, or 10 people, yes. So it's 10 times 9 times 7 times 6 times 5. So whenever they ask you how many different ways can you arrange 50 items, you say 50 all the way, 50 times 49 times 48 all the way up to times 1. And sometimes if you have got your calculator, this can be written as 10 factorial, and that's another story. 10 factorial just simply means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that is case number 1. If you wanted to know how many different ways you can arrange 10 people. Let's now talk about case number 2. Case number 2. If I am talking about case number 2, 2.2. Now case number 2, we have got 5 girls and 5 boys again. But now they say, look, we want the girls and boys, we want a girl to stand next to a boy. In other words, we are calling this the alternating question. In other words, after every girl there must be a boy. After every boy there must be a girl. So I'm going to call it alternating one because I'm using an even number. So in this alternating one, they are saying if you have got a girl, the girl must be followed by a boy. Then girl, then boy. Then girl, then boy. Then girl, then boy. So that's a girl, and then finally boy. So this is one way you can arrange it. But remember, this girl here, this can be girl number 1, number 2, number 3, number 4, number 5. Now, if you look at the number of girls, it's for them to be alternating. Let's look at position number 1. Let's say we want to put a girl on this position here. How many girls am I choosing from? And I'm going to be choosing that girl from how many girls? If I am picking the first girl, I am choosing that girl from 5 different girls. So that's what I'm going to have. And the first boy, which is this one, I am going to also be choosing him from 5 different boys. Now, once I have picked the first girl and the second boy, I must now say, if I want to pick up this girl here, the second girl, how many different girls are now left? If I have already picked a girl here, it means that there are only 4 girls left. Do you see that? Now, same thing with the boys. If I have picked the first boy, it means that this position I can only choose from 4 boys. Then if I go to the next position to pick this girl here, I now have 3 girls left. And same thing here, I've got 3 boys left to choose from. And then the next one, if you look at the next one, this one and this one, I'm just going to change my color again. Here I now have 2 boys left, 2 girls left, 2 boys left, and then finally they will only be left with 1 girl to choose from and 1 boy to choose from. So if I wanted to find out how many different ways I can alternate, and then somebody will say, look, we started with girls, what if I had started with boys? Then you will say, aha, if I start with boys, then I must add again. If I start with a boy, now instead of having a girl, here I now have what? A boy. So this boy will be, I choose from 5 boys. Then the next one must be a girl, I choose from 5 again. Then the next one must be a boy, I choose from 4 boys. The next one is a girl, I choose from 4 girls, because remember, I've already picked one already. The next one will be a boy, and it will be 3 times. Another one, a girl, that, and then the next one will be a girl there. Another one, a boy, sorry, and then a boy, a girl there. And then we have got the last ones. Remember our options here, they must be very clear. The last one, we're just going to pick times 1 boy times the last girl there. So there are 2 ways. So in other words, if you are going to add this, if you add this one plus this one, you will have the number of different ways in which you can arrange 5 girls and 4 boys, ensuring that no girl is sitting next to another girl. So in this case, you have got 2 times 5 factorial for the girls times 5 factorial for the boys. Do you see that? So the times 2 means I'm adding these 2, remember. So that's how we're going to work out some questions, and then you'll probably understand how we do it. Remember, you'll use your calculator to get the total number. Right. Let's look at the next case. Now, for the next case, case 2.3, and this is also alternating. Now, let's now look at a case where we've got 5 girls again, but now we don't have 5 boys, we now have 4 boys. Now, this is a very simple case, because instead of having 2 situations, you can only have 1. In other words, the first person I'm going to pick will be a girl. It has to be a girl, because if I start with a boy, it won't work. Let me show you. Girl, boy, girl, boy, girl, boy, girl, boy, and then girl. Do you see? After every girl, there's a boy. If I had started with a boy, it will be boy, girl, boy, girl, boy, girl, boy, girl. But now remember there are 5 girls. Then it will mean that this girl is next to another girl. So when the numbers are not the same, if the number of girls and the number of boys are not the same, it means that the situation only presents you with one starting point, the one which has got more. So here we are definitely going to be starting with the girls only. So if we're starting with the girls only, then we know that, okay, fine. If we are starting with the girls only, then that means we are now going to say, if I start with the girls, there are 5 girls to start with, and then that will be multiplied with, remember the first girl I'm picking, I'm choosing from 5 girls. The first boy I'm choosing from 4 boys. The second girl now I'm choosing from only 4 girls. The second boy I'm choosing from 3 boys. Then the third girl I'm choosing from 4. Not 4, from 3. And the third boy I'm choosing from 2. And then the fourth girl I'm choosing from 2. And the boy, now there's only 1 boy left, so you're choosing from 1. Then that would leave us with only the 1 girl, which means that we are choosing the 1 girl from what? We're choosing 1 girl. So do you see that if I multiply all this, it will give me the number of different ways in which I can arrange girls and boys alternating. And that is how we apply the fundamental counting principle to alternating. When people are sitting in and alternating, we first of all looked at the fundamental counting principle with the menu. Then we looked at the fundamental counting principle with alternating. And then we looked at, and then we are going to continue to look at it when it comes to other scenarios.